All right, on to Science Notebook number 4. Please go to page 99 and address the page Science Notebook number 4. What are mechanical waves? Please also remember that you need to have your name, the date, the weather, and the group that you're sitting with, and the time. So let's add name, date, which is 3/7/18, time, group, and weather. Excellent. Okay, so mechanical waves are waves that must have a medium through which to travel. A medium is matter. So it could be liquid, solid, gas, it could be brick, it could be air, it could be water, but the medium is the stuff through which it travels. The denser the medium is, the faster the mechanical wave travels. So when you say the denser the medium is, it's just how close together are those particles. So in the solid, they're super close together, right? And in a liquid, they're a little bit farther and they slide past each other. And then in a gas, they're way far apart. Well, since the energy is transferred from particle to particle, the closer the particles are, the faster they can move. It would be like you handing something to somebody sitting right next to you. Would take a little bit of time, but if you handed it to somebody all the way across the room, you'd have to get up and walk over there, and that would take longer. So the denser the medium, the faster the mechanical wave travels. Mechanical waves come in two forms or categories. So you've got your transverse wave, which are the ones we've been talking about, and then you have compressional, longitudinal. It would make everyone's life easy if they decided which term to use, but both terms are used for a compressional wave or a longitudinal wave, so one that is not transverse. So you can think of your transverse wave looking like this, and a compressional wave looking more like a slinky. So where it's super close together and then way far apart. Super close together, way far apart. And the other thing is that the energy in a transverse wave travels that way, but the medium goes up and down. So we call that at right angles. In a longitudinal wave, the energy and the medium move the same direction. All right, so transverse waves are waves that travel 90 degrees to the matter. For example, ocean waves, seismic waves, rope waves. Those are all transverse waves. Compressional or longitudinal waves are waves in which the energy travels in the same direction. This is how sound travels. Okay, so the crest in a compressional wave is called a compression, and it's where the matter is compressed. So compressed just means it's all close together. So if you had like 6 people at your table, you'd be like all compressed. The trough in a compressional wave is where the rarefaction is and where the matter is spread out. So this is a compression. This would be a rarefaction when they're way far apart. Okay? So what you need to remember is the crest is comparable to a compression and a trough is a rarefaction. So those things go together. Go ahead and change the color for you. All right. The next thing you need to know is in a compressional wave, the amplitude is measured by how compressed the medium is. So how compressed it is. So this would be, why is it doing that? How compressed it is. So what you do is you look at for these spots right here. If you want to know the amplitude, you would measure the distance between this compression, no, the thickness of this compression, the thickness of this compression, and that will tell you the amplitude. Okay? The wavelength is measured from compression to compression. So in a mechanical, in a mechanical longitudinal compressional wave, this is the wavelength. So let's go ahead and draw that out. So you've got compressions, you've got rarefaction, you have a compression, you have rarefactions. Alright, so this would be the wavelength. This is the amplitude. This piece right here also would be like a crest. And the rarefaction part where it's all spread out would be like a trough. Okay. I have posted these notes for you. You can go ahead and copy them down. Stop the video, rewind the video, do whatever you need. And once you get done with this, I want your left-hand assignment to be to create a double bubble with transverse waves in the center. Create a double bubble with transverse waves as one center bubble and compressional and longitudinal waves as being the other. And then you're going to add the words. So what you would do is this. You would write compressional, longitudinal, okay, and this would be on page 98. And then this would be transverse. So there's your two circles in the middle. And then what you want to put is things that they have in common. So look through here. What are things that they have in common? So what do all waves have? So in the middle would be what all waves have. And I'll just do one for you. So you would do amplitude. Because all waves have an amplitude. Okay? So that gets connected to both. But if it's something that's just about a compressional wave, for instance, energy travels in the same direction. Okay, that one only gets connected to the compressional wave. You shouldn't overlap your bubbles. You should draw lines, but I ran out of room. So then everything that just refers to a transverse wave will go over here. And I will tell you that electromagnetic waves are transverse waves. We haven't quite talked about that yet. And the rest of them you should know. There's also a video link that just gives you an example of a transverse and mechanical wave. So go ahead and watch that as well. You might want to watch that before you finish this. All right. Thank you.